All right, welcome back everybody. So in this video today, we are going to be talking about equations of a line in slope-intercept form. We're going to talk about what that is. In this lesson, we're going to be writing the equation of a line from a slope and an intercept, a graph, coordinates, and sets of intercepts. We're going to use the equation to determine whether points lie on a line. We are going to identify the slope and intercept from an equation. And we're going to talk about rearranging equations. Again, we're going to draw a graph from its equation, and we're going to determine missing equation values given clues about the line. Okay, so investigating graphs of linear functions given the equation. From each equation, make a table of values and graph the line. State the coefficient on x and the constant of the equation. State the slope and the y-intercept. So we can, for any graph or function, use key points, and typically we use like -3, -2, -1, 0, 1, and 2, okay, and 3. You can just use these, but these are points that you are always going to use to graph any function, okay, so these are called key points. And all we do is we substitute in values for x. So I've got y is equal to -2, x plus 3. Y equals -2. They tell us that x is equal to -2 plus 3. Watch positive and negative values. -2 times -2 is 4 plus 3. Y, therefore, is equal to 7. And you're going to do exactly that all the way through your table of values. So take a moment and do that. I'm going to wait for you. All right. So now I have my points. So now what I'm going to do is I'm going to graph my line. So my first set of ordered pairs is -2 and 7. So -2, so remember this is the horizontal axis is your x, the vertical one is your y. So I have -2 and 7. Now I don't have enough grid for that, okay? Because -2 and 7 is going to be like up here somewhere. So don't guess. Let's move on to the next point. -1 and 5. So here's -1, 1, 2, 3, 4, 5. I have a point right there. 0 and 3, 1, 2, 3. 1 and 1. 2 and -1. Okay, now because we are graphing an equation, you need to join your points. So I'm going to use the straight line. And I'm going to plot those points. Oops. Oh, I don't want to move my points. What the heck? All right, never mind. I will draw it myself. So I'll extend this line just a little bit so I can make it nice and straight. You're going to do it with a ruler. Okay, so that is what our function is going to look like. So now let's state some values here. So it wants us to state the coefficient on the x. So the coefficient is -2. The constant is 3. Okay, so now let's do the same thing for the next one. So you can pause the video and complete the table of values. Okay, so I have my table of values here. So -3, -2.5, -2, -1.5, and -1. I do not recommend you try to plot the points for coordinate for a point that looks like this or like this. Okay, I don't recommend it. You want to do this as precisely as you can. So I'm going to start with -2 and -3. So -2, -3, that's down here. And I'll do that in pink. Then my next one is 0 and -2. Then the next one is 2 and -1. And I'm just going to follow that pattern for more points. So you do not want to just connect the dots and be done. You definitely want to extend your graphs. When you're extending your graphs, you want to extend it so you have any x-intercepts included and any y-intercepts. Okay? So now our coefficient is 1/2. Our constant is -2. Okay? So now I want you to do the same thing with the third equation. Okay, so now we're going to graph. So I have -2, -8, so that's going to be like way down here. So we're not going to include that because again, we want it exact. The next one is going to be -1 and -4. 0 and 0. 1 and 4. There's 1 and 4. And then 2, and that should be 8. My apologies. 2 and 8. Okay, so now I'm going to join my points as best as I can. There we go. Extend your line out. Make sure you include your y-intercept, any x-intercepts that are needed. Okay, so this one's a little bit different because we have a coefficient. Coefficient is 4. What's our constant? If there is no number written, our constant is going to be 0. Okay? All right. Flip the page. Now, a linear equation is an equation of the form y equals mx plus b, where m and b can be integers or fractions. I want you to highlight that. M and b can be integers or fractions. The graph of a linear equation is a straight line, always. Okay, the equation y equals mx plus b, or a function in that form, is known as the slope-intercept form of the equation of the line. The coefficient of x is equal to the slope of the line. The constant term, the b value, is equal to the y-intercept of the line. So let's go back to that previous example. So let's take a look at the slope and the y-intercept. So looking at the very first graph, I think I actually forgot to do this, so that's all right. Take a look at what our slope is. Our slope, find a point, so let's say we start from this one, and move to the next point, rise over run. Our slope, m, is equal to -2. What's our y-intercept? Well, my y-intercept is right there. So my y-intercept, and I'm just going to write it like this, y-intercept is equal to 3. What do you notice about the coefficient on the x and the constant? So your constant is your y-intercept, your slope is your coefficient. Let's take a look at the next one. Our slope, m. Our slope. So choose a point, any point on the graph. So I'm going to start here and use your rise over run. I'm going up 1 over 2. So my slope is 1 over 2, which is the same as my coefficient. My y-intercept is -2, which is the same as my constant. So my y-intercept is -2. Look at this one. So my m, what's my m? Find a point. So let's use the y-intercept. Oops, that should not have happened. I'm going to go from the y-intercept, I'm going to go up 4 over 1. So my slope, m, is 4. My y-intercept is my constant, which is 0, and that is in fact true. Okay, so if we look at the equation, let's look at the equation. I know that my slope is -2. So right over here, that -2. My y-intercept is 3. Here, my slope was 1 over 2. My y-intercept is -2. Here, my slope is 4. I don't have anything written over here, but I know that the y-intercept is 0. Okay, so back to the next page. So complete the table and use the slope and y-intercept to sketch each line. All right. So my first line, L1, the equation of the line is y equals 2x minus 7. My slope is 2 because it's the coefficient on x, and my y-intercept is the constant, so therefore it's -7. So what I'm going to do is we first begin by plotting our y-intercept, and it's -7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. And my slope is 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Now, I don't have a ruler, and using the straight line tool on this program is tough, so I'm going to plot as many points as I can. And I always label. So this is L1. Now, in pink, I am going to do L2. So my slope, it's the coefficient on the x, so it's 3 over 4. My y-intercept is my constant, so it's -1. So I'm going to start by plotting -1, and I'm going to use my slope up 3, 1, 2, 3 over 4, 1, 2, 3, 4. Up 3, 1, 2, 3 over 4, 1, 2, 3, 4. Now I'm going to go back the other way just so I can plot as many points as I can for accuracy. So now I'm going to go down 3, 1, 2, 3, back 4, 1, 2, 3, 4, down 3, back 4. All right. Let's join our points. And I'm going to call this L2. Okay, so here we have an interesting one. It's L3, so line 3. I don't have a coefficient on x. I don't even have a variable x. All I have is the constant -5, okay? So I'm going to graph this in this blue color. So slope. If there's no coefficient on x, there's no x, our slope is 0. So what does that indicate? Well, it should indicate that we have a horizontal line, right? What's our constant? Well, the only number that I have is -5, so that must be our constant. So when we graph this, we're going to plot a point where y is equal to -5, so our y-intercept, so 1, 2, 3, 4, 5 down. And going to draw as straight a line as we can right there. Okay, and I'm going to label that as L3. All right, so now L4, let's see, what color can we do? Let's do blue. Okay, so we've got here y is equal to 4x. So I have a coefficient on my x, so that is my slope. So my slope is 4. And what's my constant? Well, I don't have one, so my constant is 0. Okay, so if my constant is 0, that means that my y-intercept occurs at the origin. Okay, so I'm going to go up 4, 1, 2, 3, 4, and over 1. Okay, up 4, over 1, and I'm going to go back down the other way just for accuracy. 1, 2, 3, 4, over 1, down 4, over 1. Okay, so that is L4. All right, and now my last one. So my coefficient on my x is -4/3, so that's my slope. And my constant is +4, so that's my y-intercept. So my y-intercept is at 4. My slope is -4/3, so I'm going to go down 4, 1, 2, 3, 4, over 3 to the right, 1, 2, 3, down 4, 1, 2, 3, 4, over 3 to the right, 1, 2, 3, and I'll go back up the other way, 4 and 3. Okay, and now I'm going to draw a nice straight line, hopefully. There we go. And I'm going to call this L5. All right, so that's how we draw them. So you plot a point at your y-intercept and you use your slope to plot more points. Plot as many as you can for accuracy. All right, moving right along. Example 2, given the graph on the right, determine the slope, the y-intercept, and the equation of the line. Okay, so let's take a look at line A. So that's this one right here. Okay, and actually I think I'll do that one in blue. I'll keep the colors the same. Okay, so A. So slope, y-intercept. I always start from my y-intercept. So my y-intercept is at +1. Then I'm going to find my slope. So what I'm going to do is I'm going to find a point that is easy to spot. Don't use a point that's kind of halfway, like right there. You want to use the point, let's say, right here. So from the y-intercept, I'm going to count 1, 2, 3, 4. So it's +4. Actually, I'm going to give myself a little extra room. So it's +4 over -2, because I'm going back 2. So if I simplify that, always simplify, your slope is -2, okay? So the equation of the line is going to be, we always want to write it in y equals mx plus b, okay? So y equals, now remember, your slope is always the one that's attached to the x, okay? It's always our m value, so it's going to be -2x plus 1. Okay, so that's the equation of line A. Now let's look at line B. So that's going to be this one right here. So I always start at my y-intercept. My y-intercept is down here. It's at the origin. Therefore, it is 0. Then my slope, so I'm going to plot another point that I can see easily, like this one right here, and I'm going to count. 1, 2, 3, 4, 5, 6. So it's positive 6 over positive 1, which gives me a slope of 6. So y equals mx plus b. So my slope is 6, and then multiply by your x. My y-intercept is 0. You do not have to write plus 0. Just leave it as y equals 6x. Okay, the next one is green. So line C. So this one right here. So mark where your y-intercept is, and that is positive 3. Determine your slope. So find another point. It could be this one, it could be that one, okay? It could be this one, it doesn't really matter. I'm just going to use this one right here because I spotted it first. So I'm going up 2, so positive 2, over 1, 2, 3, 4, positive 4. That gives me a slope of 1 over 2. Therefore, y equals 1 over 2x plus 3. The next one is D. So right there, plot your y-intercept. That's negative 5. I'm losing my voice today, guys. So just bear with me. And I'm going to go down to that point right there. You could use this one right here. So I'm going to go down 1, so it's negative 1, over 1, 2, 3, 4, so positive 4, which gives me a slope of negative 1 over 4. Y equals negative 1 over 4x minus 5. I'm just going to check. Just wanted to see if anybody came into the chat room. All right, and then the last one is E, and that one is in red. Okay. So again, just like always, plot your y-intercept. My y-intercept is at negative 3. Then find another point, and then count. 1, 2, 3, 4. I'm going up 4. Over 2. Always simplify it. I have a positive 2 slope. My equation is y equals 2x minus 3. Okay. So where does that bring us now? Just a minute. Lost my notes. There we go. Okay, I'm going to stop at this example here. What I want you to do is on page 26. I don't want to go on because it's already a lot of information, so we're going to go to page 26. And you are going to do questions 1, 2, question 4. Okay, and then you're going to come back and you're going to watch the next video for the next examples. Okay, so we're going to talk about special cases of linear equations. Okay, but watch this first, do the homework. Okay, so questions 1 to 4 on page 26 of your notes. Okay, and then you're going to come back and watch the next video.